Okay, so as we discussed in the previous video, we constructed a matrix A. And now in this video, what we are going to do is converting a matrix into its row reduced echelon form. So one is row echelon form and the other is row reduced echelon form. So row echelon form REF is a matrix obtained by applying elementary row transformations, but one applies different row transformations and can get a different matrix. So REFs are not unique, but RREF, the row reduced echelon form, is a unique matrix for a given matrix. So one can apply any row transformations and still he or she will get the same row reduced echelon form, which means that row reduced echelon form is unique for a given matrix. So now we discuss the special characteristics of row reduced echelon form RREF. So what does echelon mean? Echelon means a staircase pattern, which means that all the leading entries will be in a staircase pattern, which will be quite clear when you see the example of a row reduced echelon form, which we will try to achieve in this video. In the row reduced echelon form, all the zeroed out rows, if there are any, are at the bottom of the matrix. And as I said, all the leading entries form a staircase pattern. So that's the second characteristic of RREF. And the third characteristic is that below and above every leading entry, all the other entries in the column are should be zero. So enough said. Let's construct the let's construct the matrix and then convert it into its row reduced echelon. Okay, so first we construct the matrix. The same matrix, A equals A equal to 3 1 2 5. 1 2 minus 1 2 4 3 1 and 7. So this is the same matrix which we did in the previous video. So what we do now is that we convert this matrix into its row reduced echelon form. So for doing that, I have already written the steps. So I'll just paste them here and then I'll explain it to you. So these 6 steps are done to convert this matrix into its row reduced echelon form. So I will explain you just the first step, and all the other steps are similar to that. It's just the computerized way of doing what we have manually done in our previous classes. So in the third row, I have what I've done is I've taken the entire first row and multiplied it by 1 by 3. So what it does is it divides the entire first row by 3. All the other steps are similar, and it's an algorithmic approach where you select every leading element and try to make it 1, and above and below that you try to convert all the other elements in the column equal to 0. So that's what I have done in these steps. So what we now do is we try and execute this statement, and what else we can do is that we can write semicolons in each of these statements so that we do not get the individual results. So the semicolon is just used to execute these statements, but they do not get displayed in the command window. So now I execute the statement and let's see what we get. Okay, so what we get here is that is the row reduced echelon form of the given matrix A. So the leading entries, as you can see, they form a staircase pattern. And the other thing here to notice is that all the entries above and below the leading entries are zeros. So that's what is meant by a row reduced echelon form. So now just to verify that all the steps that I have taken are correct or not, whether I have performed the steps to create the row reduced matrix, what I do is I typed in a pre-written command in MATLAB, which is RREF brackets A, the matrix. So now we execute this statement and let's see what we get. So we get a similar result which we did by writing all the row transformations.